Hi students, welcome to AstraDex. Today we are going to discuss a new lesson, Electrochemistry. So this is an NCERT syllabus. In NCERT we have 10 lessons. Volume 1, 5 lessons. Volume 2, 5 lessons. So electrochemistry is a very important and also has more weightage. So before moving to the class, let me know what are the lessons which is present and also with the weightage. Solution 7 marks, electrochemistry 9 marks, chemical kinetics 7 marks, D and F block elements 7 marks, coordination compounds 7 marks, haloalkane and haloarene 6 marks, alcohol, phenol and ether 6 marks, aldehyde, ketone and carboxylic acid 8 marks, amine 6 marks, biomolecules 7 marks. So out of 70 marks, this electrochemistry lesson has more weightage, 9 marks. And that's why mostly the competency based equation is asked from this lesson. Let me move to the topic today. So now we are going to discuss electrochemical cell and galvanic cell. And what are the other topics which is present in this lesson are Nernst equation, conductance and conductivity, Kohlrausch law, electrolytic cell and Faraday's law, batteries, fuel cell and corrosion. So these are the key topics which should be focused, and this is very important lesson for theoretical and numerical based. So moving to the topic, electrochemical cell and galvanic cell. Let me introduce what is electrochemistry. Electrochemistry is a branch of chemistry which deals the interconversion of chemical energy and electrical energy. So once again I am repeating, it is a branch of chemistry which deals the interconversion of a chemical energy and electrical energy. So coming to electrochemical cell. What is this electrochemical cell? Cell is a device or an apparatus by which the redox reaction takes place. So when we hear this redox reaction, we have discussed in 11th standard in volume 2, redox reaction. The name of the lesson is redox reaction. What is redox reaction? It is a type of a reaction by which oxidation and reduction takes place simultaneously. And even in 11th standard we have taken the Daniell cell as an example. We can say electrochemistry has started in 11th standard itself as an introduction part. So let me move. What is electrochemical cell? What is electrochemical cell? A device that converts chemical energy into electrical energy through a spontaneous redox reaction between the two substances. So what is electrochemical cell? A device which converts electrical energy into, chemical energy into electrical energy through a spontaneous redox reaction between the two substances. And here the example we are going to discuss is a Daniell cell. It is a classic example. We have number of cells by which it has two half cells. But here in Daniell cell we have zinc and copper as an electrodes. And in the right side you can see one example which they have given as a battery energy conversion example, lithium ion battery. So this is a symbolic representation which you can see the electrons, how the flow of electrons takes place and makes the chemical reaction and the passage of electricity from one electrode to the other electrode. But we are going to detail about the Daniell cell in today's class. So in Daniell cell there are two electrodes, one is zinc, another one is copper. But the Daniell cell uses zinc and copper electrodes immersed in their respective salt solutions. So the overall reaction can be written as zinc plus copper 2 plus gives zinc 2 plus plus copper. In this zinc has been oxidized and copper is reduced. Right. Let me recall what is oxidation. Oxidation means loss of electron, addition of oxygen, removal of hydrogen. Or simply we can say LEO, L-E-O. And what is reduction? Reduction means gain of electron, addition of hydrogen and removal of oxygen. In simple we can say GER, G-E-R. So in electrochemistry, this redox reaction is explained as fully based on the electrons. So this is the Daniell cell construction. So this diagram is given in your book. You can see two beakers by which each electrode is dipped in a separate beaker in their corresponding salt solutions. In redox reaction, there are two types. Direct redox reaction is there, indirect redox reaction. That means, in case of a direct redox reaction, the oxidation and reduction both will carried out in same container. That is direct. Indirect redox reaction means both the oxidation and takes place in two separate containers. So here this is an example for an indirect redox reaction by which two separate containers, one container consists of zinc electrode, the another container consists of copper electrode, and here in the left side the zinc will undergo oxidation and in the right side the copper will undergo reduction. So reduction and oxidation takes place simultaneously, so that's why this reaction is called as a redox reaction. So this is a cell construction. In simple way you can easily understand. In external circuit you can see the wire with the voltmeter and arrows, and internal circuit you can see there is an inverted U tube. This is an inverted U tube which is called as a salt bridge, which plays a major role in the cell. It maintains electrical neutrality and this only completes the circuit. And the salt bridge is mostly filled with KCl. KCl is being taken here. And coming to the half cells. So if you take a cell, it has two half cells. One half cell is an oxidation, the another half cell will undergo reduction. Here the zinc half cell is undergoing oxidation reaction which is acting as an anode, and a copper half cell is acting as a cathode by which the reduction will take place. What is anode and what is cathode? These two are simply said to be as an electrodes, but if the electrode undergoes oxidation is said to be as an anode. If the electrode which undergoes a reduction, there is gain of electron, is going to act as a cathode. Here the zinc electrode is dipped in a zinc sulfate solution and copper electrode is dipped in the copper sulfate solution. If we dip the electrode in the corresponding salt solution, three cases will happen. One, it may lose electron, or it may gain electron, or it won't do anything. Just simply it will be as it is. But coming to the case, here the zinc is going to lose and copper is going to gain. Not simply placed in separate, because when it is connected in a circuit, such a reaction will take place and then only it will produce as the EMF. And next we are moving to the working of the Daniell cell. As we know, oxidation will take place at the anode and reduction at the cathode. Oxidation, we said loss of electron. Here you can see the zinc is one electrode, right? So zinc has been losing 2 electrons and forms zinc 2+ ions that will be dissolved into the solution, and copper 2+ will accept the 2 electron and it will deposit at the cathode, at the electrode as copper metal. So here zinc loses electron and copper ion will gain the electron, and zinc will dissolve into the solution, whereas a copper ion deposits on the electrode. Coming to the convention, as you know, when there is a flow of electron in one direction, the current will flows in the opposite direction. And here the electron flows from anode to cathode. So once again I am repeating, the electron flows from anode to cathode. whereas the current direction as per the conventional current flows from cathode to anode. Just it is opposite to the electrons. And here overall reaction is given again. Zinc plus copper 2 plus gives zinc 2 plus copper. And on connecting the two electrodes by means of a wire and the salt bridge, it produces the EMF of 1.1 volt. Let me move to the next one. Functioning of Daniell cell. So as we know that the Daniell cell produces the EMF of 1.1 volt. If we supply an external voltage which is greater than 1.1 volt or less than 1.1 volt or equal to 1.1 volt, what happens to the cell? So these are the three cases, and very important cases, A, B and C. So this diagram is also asked in 1 marks, and based on the external voltage which is greater than 1.1 volt, it was on a repeated question. The question is mostly asked like this: what happens if external potential applied becomes greater than the E0 cell of an electrochemical cell? So this is the most repeated question. So you have to give more importance to this content. So now let me move to the case number 1. When external is less than 1.1 volt means it will be as it is like a Daniell cell. The current flows from zinc, copper to zinc, where the electrons will flow from zinc to copper. Please don't confuse the word. The electrons will flow from zinc to copper, whereas current will flow from copper to zinc. And here, once the current flows from copper to zinc means zinc dissolves at the anode and copper deposits at the cathode. Case number 2, when external is equal to 1.1, no current. Okay, that means no flow of current means no current. And no chemical reaction takes place because at that time it attains an equilibrium. And third case is when the external voltage is greater than 1.1 volt, the electron flow from copper to zinc and current will flows from zinc to copper. And in this case, the zinc is deposited at the zinc electrode and copper will get dissolved in the copper electrode. Can you able to differentiate these two? Because here this is actually less than and this is actually greater than. So if you compare these two, when the potential, that is the external voltage which is applied, is greater than 1.1 volt, the electrochemical cell is converted to the electrolytic cell. And what is this new term electrolytic cell? What we said for electrochemical cell? It is a conversion of chemical energy into electrical energy. Whereas by means of passing the electrical energy, we can make the chemical reaction to undergo. So that's why it is opposite we said. So just a quick review. What is the effect of external potential on Daniell cell? So the behavior of a Daniell cell changes depending on the magnitude. The magnitude in sense the amount. Okay. How much amount of external potential I am applying to the cell. So depends on that. These three cases will happen. So these three just now only we have discussed. So just a quick review again. Cell operates normally as a galvanic cell. But in case of external is equal to 1.1, no current flows. Because what we said, it will attain the equilibrium. The system is at an equilibrium. Okay, null point. There won't be any deflection in the galvanometer. And coming to external, which is greater than 1.1, the cell will act as an electrolytic cell. Okay, just the electron flows reverses. So whatever the thing which is happened in electrochemical cell, just it will reverses in electrolytic cell. Okay, right. Let me move to the second topic, galvanic cell. So simply we can say the galvanic cell, or otherwise called as a voltaic cell also. Okay. So galvanic cell also called as a voltaic cell. So coming to the voltaic, so many of you will be recalling that when you hear the voltaic cell, which was discovered by a great scientist, name is Alessandro Volta. Yes. You know very well the electrochemical cell is a spontaneous redox reaction, whereas electrolytic cell is a non-spontaneous, because we are supposed to do the reaction. Okay. So galvanic cell, also called as a voltaic cell, which converts a Gibbs energy of a spontaneous redox reaction directly into the electrical energy. So still we are in the discussion about electrochemical cell. This galvanic cell is a electrochemical cell. Okay. A neat diagram which was given here. You can easily observe the zinc. This is a zinc electrode and this is a copper electrode. And here you can see what happens. The zinc will dissolve into the solution as zinc 2 plus and the electron will be left in the electrode itself, and by means of that only it flows from one terminal to the another. And here this is a copper to my right side. Copper Cu2 plus ion which is present in the solution. By means of accepting the 2 electrons, it will deposit as a copper at the copper electrodes. And the KCl which is acting as a salt bridge, okay, the sulfate ion. So actually we said that by means of moving, we just see zinc will convert into zinc 2 plus and copper 2 plus will convert to copper. One side there is a flow of electron, but other side there won't be any neutrality of the ions. To make that neutrality, if suppose this reaction has been taken place without the salt bridge, means no such a current will be drawn. Okay, so that's why if we connect with the salt bridge, then only the reaction will take place and for a long time, as well as the EMF will be produced is also more. So the driving force is the difference in electrode potential between the two half cells. No external power source needed. So this is a driving force in sense what we said earlier. When we place an electrode in the electrolyte, it may lose or it may gain or it may be just kept quiet. That means nothing been done. Okay, so by means of that driving force only, any one of reaction will take place. So if one is losing, another one is gaining, in sense definitely there will be a flow of electrons will take place. Okay. So again and again, please register this in your mind. This galvanic cell or electrochemical will undergo a spontaneous redox reaction, and electrical energy is an output. And here anode which undergoes oxidation, in cathode it undergoes a reduction, and here the Gibbs energy releases, because you know very well spontaneous reaction in sense the Gibbs energy will be releases as we will say del G is negative. Okay. So this is a small difference between the galvanic cell and electrolytic cell. External voltage is not required because it is going to provide the voltage for us. But for electrolytic cell it requires external voltage. And reaction type, coming to reaction type, spontaneous, it takes by itself. Okay, it takes by its own. Whereas electrolytic cell we have to supply energy, so non-spontaneous. And what is the energy conversion? When the chemical energy is converted to electrical energy, it is electrochemical cell. When electrical energy is converted to chemical energy, it is electrolytic cell. What about the electron flow? Anode to cathode is spontaneous. But when we supply, driven by the external source, that means opposite cases will happen. Example is Daniel cell, dry cell, and here electrolysis of water. Not only electrolysis of water, we have so many examples we are going to discuss in upcoming classes. Okay, and this is a small note. In galvanic cell, anode is a negative, cathode is a positive. Okay, but in electrolytic cell, anode is a positive, cathode is a negative. Excuse me. Right. So these are the topics we are going to discuss in detail in upcoming classes. Just a small recap. What is electrode potential? What is a half cell? A cell consists of two half cells. Okay, a cell consists of two half cells. So you should understand what is meant by half cell. Okay, and how to write the cell representation, that also I will discuss now. So understanding half cell. So each electrode and its solution form a half cell. So if I take an electrode and a beaker containing electrolyte, if it is kept separately, it is not said to be as a half cell. If I take that electrode, when it is dipped in the electrolyte, then that is considered as a half cell. As like that, if I take another set of a half cell, when it is connected by means of a salt bridge and external wire, it will be said to be as a complete cell. Okay. So two half cells combine to make a complete galvanic cell. Okay. So here you can see this diagram has left side is a reference electron and right side is another half cell. Okay, so this is nothing but we used to say she. Who is she? She means standard hydrogen electron, which is called as a reference electron. Okay, this is a half cell diagram which is given. So we have a detailed discussion about it. In upcoming classes we will discuss. So at present you just to know what is this half cell means. So half cell means it consists of an electrode and an electrolyte solution. Okay. So in this, the she will act as a reference. The EMF of the she is 0.00 volt. So coming to oxidation half cell, that means losing. Reduction half cell means gaining. Okay, please remember this word. Oxidation means loss of electron. Reduction means gain of electrons. Okay, so this is a metal will loses electron. In case of oxidation, metal ion will gains an electron and it is said to be as a reduction. And standard electrode potential is nothing but standard. When I say the word standard, these are the conditions should be followed. That means standard electrode potential. The condition number 1, it should have the temperature is 298 Kelvin and pressure is 1 atmosphere and the concentration of the solution should be 1 molar. And that's why it's said to be as a standard. Okay, standard electrode potential. Here the standard hydrogen electrode will be measured at this conditions. 1 atmosphere, 1 molar concentration, 298 Kelvin. Okay, we will discuss. What is cell potential and EMF? Defining cell potential. This is again a very important terminology which is asked in board. The cell potential, that is EMF, is a difference in electrode potential between the cathode and the anode. So it drives the electron flow through the external circuit. Okay. So cell potential, that is one the term we use now, EMF, electromotive force. Okay, it is a difference in the electrode potential between the cathode and the anode. Please remember the word cell potential is different from electrode potential. Okay, if the two electrode potentials are connected, that means if I take the two beaker, oxidation reduction, oxidation will have some electrode potential, reduction will have electrode potential. The difference between the two only is said to be as a cell potential. Okay. So coming to the E cell. How can we calculate the E cell? This is a formula. We used to simply say as E Ka. That means Ka in sense CA. C for cathode and A for anode. Or else we can write RL. That is R for right, L for left. So if I take any, I'll go to the previous one. If I take a setup, this Daniel setup, you can see the two beakers which is present, no? If the question is asking like this, in which beaker the oxidation will take place, in which beaker the reduction will take place, means it's very easy to say that always the reduction will take place on the right side. The oxidation will take place on the left side. Okay, so the left side is nothing but anode. The right side is cathode. Okay, left side means it is an oxidation, right side means reduction. So that representation alone here has given us E cell, that means E right. Who is on the right? Cathode. And what about the E left? E left is nothing but anode. So whatever the potential which is being measured. And here for Daniel cell, we have for copper is plus 0.34 volt and for zinc is minus 0.76 volt. Okay, so let me come to the next point now. A positive E cell indicates a spontaneous. So it's a very, very important line. Spontaneous. Okay, so if I am getting the value in positive, it means that reaction will take by itself. Okay, by its own. So here, this is cell representation. If I am asking you to draw the Daniel cell, you will find some difficult to draw the beakers, electrodes, wire connection. Instead of that, this is cell representation, which is very easy to write And again, often this will be asked in 1 mark, even in a 3 mark combinations. Okay. So if a cell has been given and they are asking you to write the cell representation, you can follow this model. So here, this is zinc rod, this is copper rod, this is for Daniel cell I am explaining. The center, the double vertical line is given, no, that means it represents as a salt bridge. And outer they have given the arrow, that doesn't matter. And here one vertical line is present, no, that vertical line is nothing but, which means between the metal and the metal solution. And here again a metal and a metal solution. Okay, so here I am going to write the cell representation. So cell notation we can say, by convention we said just now, anode is taken in the left, cathode is taken in the right. Okay, anode is on the left, cathode on the right. So for Daniel cell, how they have written, so this is a reaction which has been taken place. So a simple case, here I will write metal, first metal, vertical line, metal ion, here I have to use N plus, okay, it may be any number of electrons, double vertical line, again metal, N plus, vertical line, metal, another metal. Here this metal and this metal will not be similar. Okay, if it is similar means it will be a separate case, another case will be studied in later. But here in Daniel cell, this M represents zinc, whereas this M represents copper. Okay, so here you can see that, so in this zinc solid form, vertical line, metal, okay, metal which is been where the electrode is dipped in the electrolyte, no, so that's why zinc 2 plus, solution form, double vertical line between the two beakers who has been connected as an internal circuit, salt bridge, so that is been represented by double vertical line, copper 2 plus, again solution in which the electrode dipped is copper. So now you can see zinc vertical line, zinc 2 plus, double vertical line, copper 2 plus, vertical line, copper. Okay, and here you should not change this order. Cu2 plus first you have to write and next you have to write Cu. That means the salt bridge which has been connected between the two solutions. Okay, here the solution and here also the solution. Ionic form is been mentioned as solution. Okay, and here how can we write the E cell or E naught cell? If I am simply writing E cell, it is just cell potential we are saying. When I am saying E naught, it is a standard electrode potential. Okay, standard electrode potential. That naught is represents standard. Here E naught cell has been calculated. What is the formula we said? Right minus left. Okay, here which beaker is taken as a right? Cathode is taken as a right. So this is right. So copper slash, that is we used to read as a copper 2 plus couple minus E naught of zinc 2 plus zinc couple. Okay, so the value for copper is 0.34 minus of, what is it? Zinc 0.76, isn't it? 0.76. So minus 0.76. So if you add it, we get the answer is 1.10 volt. So that's all. We are nearing to the end of a session. So what are the concepts we learned in this class? What is electrochemical cell, which converts chemical energy into electrical energy via spontaneous redox reaction. What is Daniel cell? It has two electrodes, zinc and a copper, where zinc undergoes oxidation, which is anode, copper undergoes cathode, which is undergoing reduction. And what is the EMF of the cell? 1.1 volt. What is the use of the salt bridge? It maintains a neutrality. And galvanic cell is also one of our electrochemical cell by which it converts the electron, that means chemical reaction, into the electrical energy. Okay. No external sources been needed. And the formula for cell potential is E cathode minus E anode. And if the value is positive, it is a spontaneous. If the value is negative, it seems to be a non-spontaneous. Okay. Thank you, students. Keep revising these concepts for your board exam. Thank you.